Hi students, today I am going to explain in chemical kinetics. So what is rate of reaction, what is order of reactions and different types of order of reactions like zero order, first order, second order reactions. So let's first start. What is chemical kinetics? Chemical kinetics is a branch of physical chemistry which deals with the study of speed of chemical reactions. So chemical kinetics is the study of how speedily the chemical reactions will takes place. So speed also we can say rate of a reaction. So what is rate of reaction? It is the amount of chemical change occurring per unit time. So in per unit time, how much chemical change is going on? So that amount is nothing but a rate of a reaction or a speed of a reaction. So how we can express it? Rate is equal to K A to the power of N. So for reaction, A is a reactant to B is the product and K is the rate of the reactant and it is a constant of rate. So K is rate constant, N is the order of the reaction and A is the concentration of the reactant. So how much concentration of the reactant is there, and so rate depends on the reactant concentration, how much amount of reactant is participating in the chemical reaction, that is playing a great role in the rate of a reaction. So rate is equal to R is equal to K A to the power of N in the case of only a single reactant is taking place to form a product. So then when two reactants like Na plus Mb gives products, so rate is equal to K A to the power of N, B to the power of M, where N and M are the order of the reactions and AB are the reactants. So like this we can say when two reactants are taking place. So then I told order of reaction. What is order of reaction? It is the number of concentration terms on which reaction rate depends. So it is the concentration terms, how many are there, number. So on which this rate of reaction, speed of the reaction is depending. So order of reaction is of different types. Zero order of reaction, first order of reactions and second order of reactions. So what is zero order of reaction and how its kinetics is there? Let's see. So zero order kinetics we'll study first. A reaction whose rate does not depend on concentration of reactants. If the reaction, chemical reaction which is going on, it will not depend on the reactant's concentration, amount of reactant, then it is called zero order reaction. And the rate of the reaction we can write like this. So rate of the reaction dx by dt is equal to K, where K is nothing but constant. So dt will go this side, RHS side. So dx is equal to K dt. So on integration of this side, dx is equal to K psi dt, where C is when we take C is equal to integral constant and x is equal to 0, then we will get this x is equal to kt, x is equal to kt plus C. So where C is equal to integral constant and we take 0, so that is equal to x is equal to kt. This is when we draw a constant x and time in a graph, we will get like this, a straight line originating from the origin. So like this we can say for a zero order reaction. And example of zero order reaction is photochemical combination of hydrogen and chlorine to form HCl. So hydrogen and chlorine react together to form HCl, and hydrogen and chlorine's concentration will not play any role in the formation of product or the rate of the reaction, because it is photochemical combination, photochemical. So the light, the energy of photochemical, how much it is present, that much fast the reaction will takes place. Then if we want to calculate the half-life of the zero order reaction, let's see what is half-life first. Half-life means it is a time taken for half of the initial amount of the reactant to disappear. So whatever is the initial amount of reactant, first reactant, how much is there, in that half of that to disappear and to form as product, how much time is taken, that is nothing but half-life. So half, this one only I am writing. So x0 is equal to kt. So because of half-life, half x0 is equal to kt half, because time is half. So is equal to, let's take this one here. So T half is equal to half x0 by k will come here 2k. So x0 by 2k. So x0 is nothing but initial concentration. It is reduced to half in the time. So half-life depends on the first concentration, how much concentration of the reactant initially it is present, and also the rate constant k. So T half is equal to x0 by 2k. Then first order kinetics. So we discussed about now, already we discussed zero order kinetics. Next we are discussing first order kinetics. If the rate of reaction is depend on the first power of the concentration of reactant, it is called first order reaction. Means only one reactant will be there. So the rate of reaction and depend on that reactant. So rate is equal to rate constant K C1 or Ka, where A is the reactant. So we can write K into A minus X. A is the initial concentration minus how much product is formed. So the rate of reaction is directly proportional to the concentration. So rate is directly proportional to the concentration of the reactant. So we can write like this: dx by dt is equal to Kc minus dx by C comes here, by C is equal to K dt. By differentiation, so minus 1 by C dc is equal to K side dt. Integration in C is equal to Kt plus C. So like this we can do. C is a integral constant. So after that, so CO is a initial concentration of reactant when T is equal to 0 and C is equal to C0. Then integral C0 C is equal to integral C Kt minus integral C0. So C0 by C is equal to Kt. So this we reversed, so e to the power of minus Kt, that is equal to C0 minus C is equal to C0 in the bracket 1 minus E minus Kt. Like this, the first order reaction we discussed. In first order reaction, C is equal to, what is C? Integral constant is equal to CO is the initial concentration of the reactant into e to the power of minus Kt. The reaction cannot be complete because C would become 0 at any infinite time. So in first order reaction, the reaction cannot complete because C may become 0 at any time, and the quantities A by A minus X or C0 by C is ratio of concentrations of both. So its value may be same whatever the units we can use. So K is equal to 1 by T in A by A minus X. The equation in A minus X is equal to minus Kt in A. This is only rearranged. So we will get log A minus X is equal to minus K by 2.303 into T plus log A. So when we draw a graph between log A minus X and time, we will get the slope like this. That the slope of the line is nothing but minus K by 2.303. So next we discuss what is half-life of the first order reaction. So we can say X is equal to A by 2. So initial how much the reactant is, in that half the reactant how it is disappeared. So half-life period time half-life is T half is equal to 1 by K in A by A minus, in place of X we are writing A by 2. So this is one only. So K is equal to 1 by T in A by A minus X. In the T we shifted here and K here. So T half, because it is half-life, is equal to 1 by K in A by A minus 2. So by doing all that, we will get the value 0.693 by K. We will get 0.693 by K. So this is the half-life of first order reaction. Then what is second order kinetics? We see when the rate of the reaction depend on the product of concentrations, because two reactants are participating here to form products. So the two reactants product is depends on the rate of the reaction. So when the two reactants are same, then in the first case rate is proportional to the square of the same reactant concentration. If the same reactant is taking place in the chemical reaction, then the rate is proportional to the square of the reactant concentration. So dx by dt is proportional to A into A. So both are same reactants. So K into a is nothing but a minus x into a minus x, that is equal to k into a minus x whole square. So dx by we bring a minus x here, so dx by a minus x whole square is equal to k dt on differentiation. So we will get 1 by a minus x is equal to kt plus c, and when we calculate half-life, k is equal to x by at into a minus x, or we can write half-life because time, so we just interchange this. T is equal to x by ak into a minus x, where x is equal to half-life, so half the concentration of reactant, so a by 2. So T half is equal to x plus, you write a by 2 ak into a minus, again here x, a by 2. So by all doing the calculations, we get T half is equal to 1 by ak. Then, so time required for the half the amount of reactant to undergo change is inversely proportional to the initial concentration. How much time it is taking for the half of the reactants to undergo change is the inversely proportional to the initial concentration. If more initial concentration, then less time is required. Less initial concentration, more time is required, like this. Then the rate of reaction is proportion to the product of two reactant concentration. When the two reactants are same, we saw. When they are different, so a plus b is equal to product, then product of these two, so dx by dt is proportional to a into b, that is equal to dx by dt is equal to k, which is constant, a into b. So a you can write a minus x, b we can write b minus x. So dx by dt is equal to k into a minus x into b minus x. So dx we are bringing this down. So a minus x, b minus x is equal to k dt. So on integrating we will get 1 by a minus b in a minus x by b minus x is equal to kt by plus 6 kt plus c. So again we are doing all the calculations required. K is equal to 1 by t into a minus b in b into a minus x by a into b minus x, like this we will get. And to calculate the half-life also we want this. So instead of here t, we will exchange here and k here, so that t is equal to 1 by k a into a minus b in b a minus x by a into b minus x. So when we draw a graph between log b a minus x, this one, log b a minus x by a b minus x in with time, we will get slope 2.303 by k a minus b, like this we will get. Thank you. Then what is rate constant? K is equal to, in the case of zero order reaction, x by t, where x is initial concentration and t is time. Then whereas in the first order reaction, k is equal to 2.303 t log 10 a by a minus x. So then in case of second order reactions, k is 2.303 t into a minus b, because two reactants are taking place. So a minus b log 10 b into a minus x by a into b minus x. Then, so what is half-life? So half-life of zero order reaction is x0 by 2k, where x0 is the initial concentration and k is the rate constant. So half-life depends on both the initial concentration and the rate concentration. Then half-life period of first order reaction is 0.693 by k. It depends on the k. Then T half is equal to 1 by Ka in the case of second order reaction. So Ka is nothing but a initial concentration proportion. So second order reaction half-life is inversely proportion to the initial proportion of initial concentration. If more initial concentration, then less half-life. Less initial concentration, more half-life, because it is inversely proportion. Then if we see graph between in a zero order reaction between concentration and time, we will get the slope like this originating from the origin. So K is equal to x by t. Then for first order reaction, if we draw a graph between log a minus x by t, so we will get a slope minus k by 2.303. So and for second order reactions, log b to the power b into a minus x by a into b minus x and time, we will get a slope originating from the origin, and the slope is 2.303 by k into a minus b.